Yeah, thanks very much, Ron. My name is Mitch Carlson. I'm the Director of Business Development with HTEC, Hydrogen Technology and Energy Corporation. HTEC works across the hydrogen supply value chain. We provide low cost, low emission hydrogen to our customers. We're based in North Vancouver and we were established around 2005. And we were really pioneers in the hydrogen fueling solutions in Canada. So this includes support that we provided to the development of the Whistler Bus project back for the 2010 Olympics, which at the time was the largest hydrogen fueling station in the world. There was 20 buses, fuel cell buses that ran for over 3 years at that time. So really a huge success story in hydrogen fuel cells at the time. We're also the first to open a retail fueling station in Canada for hydrogen, and that was in 2018 in Vancouver. We've since added a small network that we're expanding here. We have 4 stations open right now in BC. We also have a station in California, and we operate a station for Toyota in Quebec. We're continuing to expand our network of fueling stations across Canada and providing additional demonstration fueling solutions as we go, and that's what I'll talk about a little bit here today. If you want to go to the next slide, Ron. It's a little bit more about what HTEC does. You can see in the middle here, we do hydrogen production, hydrogen distribution, and hydrogen dispensing and fueling systems. We kind of consider ourselves the glue that binds together the elements of the hydrogen supply chain. So we have expertise in all of those areas. We will partner with people on the upstream end to get a clean energy supply, and also partner on the downstream end with groups like Ballard, who do the fuel cells and the vehicles, the OEMs. So at the bottom there, you can see that we've worked with Toyota, Ballard, and Hyundai, who really are the ones that are putting the vehicles on the road. And we provide that infrastructure that in between. So we have 2 main business platforms. One is where we create the infrastructure, build, own, and operate it ourselves. And the other is a technology solutions platform where we help others to do kind of what we do. So that would be through project development, engineering design. We do a variety of specialty and packaged products related to hydrogen. And we also do operations for third parties. So a variety of things that we provide to our clients through that. You can go to the next slide, Ron. Today I'll be talking about some of the various styles of infrastructure and fueling stations that we've developed and that we can provide to our clients. So that will range from retail fueling stations that you can see here, where we've integrated right into the middle of an existing fueling station. We've done that with Shell and 7-Eleven Esso. We could also do standalone behind the fence type of facilities. The Whistler Bus project station there is shown in the bottom left. And I'll talk about some of the distribution equipment and how we get production done as well. So you can go to the next slide, Ron. As far as fueling infrastructure goes, we have a few different options that we can provide. We've developed mobile fueling solutions that we've been using for demonstrations. So at this time, there are some commercially available vehicles for hydrogen. That's a couple light duty vehicles and buses. And we're progressing to see more into the heavy duty side, trucks coming along. But right now, some of those would be considered kind of pre-commercial. And so there's a lot of demonstrations going on around North America, and we've been looking to provide mobile fueling solutions to really help cut down on the cost of infrastructure at those early stages. And once that technology is proven out and the fleets are comfortable with what they're seeing on the vehicle side, then we'd be moving into more of a permanent fueling station installation. And that can come in a variety of flavors, and I'll explain that. And then we'll talk a little bit about how we actually get that gas produced and moved to you. So next slide, please. So here's one of the options that we've created for our mobile fueling solution. We've been using what we call our power cubes, which is high pressure gaseous storage that is Department of Transportation approved and Transport Canada approved for on-road use. So the modules that you see on the flatbed are at high pressure, 450 bar pressure. So we would compress gas, hydrogen gas into those, and then we can distribute that on the road. We use this to distribute gas through our network. So from a centralized electrolyzer that we have here in BC, we distribute that to our 4 retail network stations here in BC. But we're also starting to use that in combination with the dispenser that we have that you see at the bottom right here. And that combination allows us to actually do fueling on site to heavy duty vehicles that are at 350 bar. So the device in the bottom is really just a control, a sophisticated control valve that allows us to control that flow of gas from the high pressure storage into the vehicle on board. And what it does is it really brings the cost of capital down for some of these demonstrations that you'd be requiring. We can zip by kind of just like a fueling truck. We'd be lacking is that there's no compression on site and no chilling. So you would expect a little bit of longer fueling times than you would from a typical retail station. But it really allows you to get that feel to demonstrate the vehicles downstream. So that's one of the technologies that we've been using. We've got a project with the Port of Los Angeles where there'll be 2 yard trucks that are being demonstrated, and we're providing that fueling station for that. And in Alberta, we will be involved in what is called the Ace Tech project, which is 2 long haul trucks that will be going from Edmonton to Calgary and back on a single fill. And we'll be providing the fueling for that using this type of technology as well. We have also developed a fully mobile containerized station that does include compression and dispensing on it. I don't have a picture of that actually, unfortunately, in this slide deck, but it's another thing that we've created as a different style that basically we've taken a retail station, put it on the back of a flatbed trailer. A little bit higher capital cost for that one, but just shows you some of the flexibility that we have in our solutions. Go to the next slide, Ron. When you start moving into a permanent fueling solution, there's multiple configurations that you can consider. This is one that we have here in California. We actually do on-site hydrogen production with an electrolyzer. It's quite a small electrolyzer at that facility, but then that's combined with what you typically have for storage, compression, and dispensing in a normal retail station. In this case, though, we do have that on-site production where we can produce hydrogen using electricity and water right on site. And then we could also supplement that by bringing in gas in tube trailers if we need additional supply. So that style could be used to scale up to larger fleets as well. I know there's transit agencies in California that are doing their own on-site production, and some of them are even tying into their own solar array that they have. It really depends on the property and the spacing that you have, but that's one of the ways that you can go. The next slide, Ron. Another option is that you would, like I said, you can bring gas in from off-site. So the one that you're seeing here is a little bit different style of a station. We've actually containerized this. This is one that we had built for Toyota, and it's sitting in Quebec City right now. And all the compression, the storage, and the dispenser is right inside that one container. To do larger fleets or to expand that, we would just add external hydrogen storage in the back. So you can just maybe see in the back corner behind that second car, you can see the front edge of a tube trailer in the back, and that would be one way of getting additional storage on site. So you can continue to expand that storage. Generally, the compressors are designed to do a large volume of fleets. You may want to add some additional compression and redundancy around that, depending on how big of the fleets that you're using. But the benefit around this is that it is containerized, so I would consider that a semi-mobile type of station where we would have the ability to move that around. The difference between what we showed from some of the mobile applications is that this would, because there's compression and everything on site, is that you would have additional requirement for higher power connection, generally a 480 or 600 volt connection. Whereas that mobile fueling solution where we didn't have any compression, we'd probably just need about a 120 volt to do some of our instrumentation on that. So you can go to the next slide, please. And then as you scale up even further, if you're looking to a fleet of maybe 20 buses or 20 long haul kind of larger vehicles, where you're going to have a lot of demand, you're probably looking to go into a liquid storage at that time. So that was what was designed for the Whistler station that's shown here again. And even some of the larger retail stations in California now are having liquid storage. So you can see in the vertical tanks here, that's actually quite a large amount of storage. I think they required 5 days of full redundancy for that station at the time. So quite a large amount of on-site storage. And then rather than doing compression, they actually do liquid pump and vaporization, and then it gets high pressure gas still goes into the vehicle. But all the storage or most of the storage on there is in liquid form. So it's just different ways that you can see that we can scale up your hydrogen fueling station here. So Ron, you can go to the next slide. Just some of the activity that HTEC is involved in. As I mentioned, we've got a station network in BC. So all these highlighted in blue are the jurisdictions that we're currently active in. Of course, we're looking to fill in all the grays here as we go as well. But we do have production facilities here in BC, and we're looking to expand that where we'll do our own electrolyzers using the clean electricity grid. There's also byproduct capture. So facilities such as sodium chlorate plants produce hydrogen that's often just vented to the atmosphere. And we'd be looking to clean up, purify that stream. And a lot of that's quite high volume. So we might even probably be considering liquefying that and then distributing that through liquid. That's on the Quebec side of things. On the other side of the country, the supply chains or the established, there is already established production there, and a couple of those are actually using those byproduct plants right now. So Air Liquide has one in Bécancour and Messer in Magog, Quebec, and I believe both of those are with on byproduct. In Alberta, like as I mentioned, we're doing a heavy-duty demonstration project. We'll be using blue hydrogen for that, where as you be aware, there's some carbon capture facilities in Alberta where they would use SMR, natural gas production for hydrogen, and then strip off the carbon and put that underground. And there's two different established options that they have right now. Is Shell's got their Quest pipeline, and then there's the Alberta Carbon Trunk Line. That is another place that they take that carbon and sequester it underground. From there, we would be the ones that can help you to distribute that gas and bring it to your facilities. And in California, again, we're doing some of that distribution and fueling stations of various setups for that. And then the next slide, I think that might be it for me. Yeah, if you have any questions about some of our technologies and how we can get the gas supply to you, please don't hesitate to follow up at the end here.
So thank you very much, Mitch. And Terry, why don't you take it from here and go with the Ballard presentation, and then Mark can take it from there.
Sounds good. There we go. Okay, apologies for the fumble before.
If it wasn't for technical problems, it wouldn't be a webinar if it wasn't for technical problems,
yeah.
right?
Okay, back to a little bit about Ballard. So we've been doing PEM fuel cells for 42 years now. There's various types of fuel cells, but PEM is the sole type that we do. And we're a little different than some fuel cell companies in that we go right to the core IP of what's included in a fuel cell. So Ballard manufactures our own MEA, we manufacture our own bipolar plates, fuel cell stacks, and the full module, where where many of the others in the market are really buying MEA from a third party and buying plates, and are more of a stack designer and assembler. So because of that, we have a significant amount of patents, so over 1,400 patents that go right to the core of the technology. We've been growing even through the COVID time, so we're actually closer to 1,000 employees now. And we have the largest fleet of heavy duty vehicles on the road today. So from a bus standpoint, we have over 1,000 buses currently in revenue service, close to 3,000 trucks now on the road. Most of those trucks are smaller, sort of 3 to 9 ton trucks that are operating in China. 5 rail projects, and more recently, we've launched a marine product, and we have 6 marine projects on the go. So I'll share some slides, more details on those applications. I think the other number that I want to share with you that's on this slide. I guess there's 2. So one is over 70 million kilometers of operation, of on-road operation, have been amassed so far with Ballard fuel cells. And our fleet leader as far as durability, so we have exceeded 35,000 hours of operation without having to replace the fuel cell stacks or the MEA within those stacks. So you'll hear a lot of numbers as far as durability goes for fuel cells. And it can be easy to misinterpret. So Ballard has traditionally focused on heavy duty applications and specifically bus applications. And in the bus world, you have to design your product. The end product really is going to run for about 50,000 hours. And we try and design our product so the fuel cell stack will last that 50,000 hours with one refurbishment in the middle. Compare that to an automotive type application. Your automobile sitting in your driveway is probably only going to run through its life about maybe 6,000 or 7,000 hours. So very different market requirements, and that drives different technology to be included. And as I said, we're sort of focused on the heavy duty applications. We are a global company. We have our head office here in Vancouver. This is where we manufacture all the MEA, the key IP of the fuel cell stack. But we also have offices in the United States. We have our Marine Center of Excellence where we develop marine modules in Hobro, Denmark. And we have 2 joint ventures within China, the largest of which is a joint venture with Weichai, the largest diesel manufacturer in the world, I think. And those 2 joint ventures have stack assembly and module assembly rights for within the Chinese market. And so products sold anywhere outside of China comes from either Vancouver or Denmark. And even the MEA that's sold within China will come from Vancouver. A little bit about the value proposition and why you'll see the applications that you see on the following slides. So when you look to provide a zero emission solution for heavy duty vehicles, fuel cells bubbles up to the top for a few attributes. So one is if you require long distance, so you don't have to sacrifice the range with the vehicle, fast refueling compared to batteries, and you're also not sacrificing any payloads. So the weight of the fuel cell solution is, I would say, close to the weight of the diesel solution versus batteries. So I've got, I think, 5 slides. I'll walk you through some of the applications. The first one, buses, it's without a doubt, it's the most commercial of the heavy duty vehicle applications. Today, in North America, there are 2 OEMs that can provide fuel cell buses, both using Ballard fuel cell modules. We're very fortunate to have New Flyer as a customer of Ballard's, and that top bus that you see is the New Flyer 60-footer bus. So they have both a 60 and a 40-foot fuel cell bus with Ballard inside. In Europe, we have 4 OEMs that utilize Ballard fuel cell modules, and in China, we have a little more than a dozen of the OEMs that can provide transit buses with Ballard modules inside. From truck standpoint, from trucks, we range from the small 3 to 9 ton trucks that you see at the bottom up to 300-ton mine haul trucks. So we have projects to deliver mining trucks to Anglo American, where we're providing 900 kilowatts of fuel cells to an integrator called First Mode in Seattle, and they will be integrating the fuel cells along with the battery, electric drive, hydrogen storage into a Komatsu mining truck. We are working with Roush in California to deliver 3 Class 6 trucks to UPS. That's the image you see in the bottom right. We've had a Class 8 drayage truck running at the Port of Long Beach for the last 2 years with a Ballard module integrated by BAE Systems into a Kenworth truck. And currently in development, or more in construction right now, is for Alberta. We're doing 2 60-ton long haul trucks that will run between Edmonton and Calgary, and each of those trucks will have 240 kilowatts worth of fuel cells inside of those. There's quite a bit going on in the rail market, so a lot of light duty rail applications. We have 2 rail systems operating currently with CRRC in China. We are commissioning currently a rail project in the UK, and we are developing, along with Siemens, Ballard is developing a specific 200 kilowatt rail certified module that will go into a new light rail train that Siemens is developing specifically for fuel cell applications. Marine market to date has been, I would say, more of a European application than North America. We have a few projects on the go here in North America that are in the design phase, but we have 5 projects in Europe that are moving on to build. So they all range from either 200 to 800 kilowatts worth of fuel cells inside. And most are compressed gas storage on board, but the middle image you see will be the very first liquid hydrogen marine vessel that will be commissioned later next year. And I think my last slide, so shifting from the transportation applications, we do have stationary power products. So we have a backup power product that's used mostly in telecom applications. That's 2 and 5 kilowatts in size. And then at the very other end of the scale, we have a 1.5 megawatt system under development. That's the next generation from our 1 megawatt system. So you see 2 images here. This is the bottom image is a 1 megawatt system that was operating at Toyota's US sales headquarters in Torrance, California. And the top image is a 1 megawatt system operating at a chemical facility on the island of Martinique. And that is just finishing its commissioning phase now. Meanwhile, we're developing a 1.5 megawatt system, and we'll deliver that through Caterpillar, and it will operate at a data center, a Microsoft data center in the US. So that hopefully that gives you a flavor for the types of applications that we're seeing, and thank you very much for the opportunity.
Great, thanks, Terry. Mark, did you want to take over?
Yeah, I will do that. So just share my screen.
Okay, this is Mark Kirby from the Canadian Hydrogen Fuel Cell Association.
Okay, I should be showing now. Is that showing full screen?
Yes, sir.
Excellent. Hello, everybody, and thank you. Appreciate the opportunity to speak here, Ron. It's a good time to be able to talk a bit about hydrogen. Actually, just on a call before I joined you guys with the Ontario Strategy Development Group, and one of the main barriers that's been highlighted is communications, and the fact that there's not a lot of information out there in the public hands about what's going on with hydrogen and fuel cells, and so there's a real need to get out and talk to people and provide some information about what's going on. Thanks very much to Terry and to Mitch. They provided some concrete examples of what is actually going on. I think what they didn't mention is that they are incredibly busy. They're seeing demand growing, seeing interest growing, and it's seeing investment flowing. So it's quite an exciting time to be in the hydrogen fuel cell space right now. I want to talk a little bit about from a higher level about what's going on. So talk about the CHFCA, why we're here, what's going on from the government's point of view in terms of the hydrogen strategy for Canada. I will touch on hydrogen vehicles, but they've been covered largely by Terry, and I'll touch on hydrogen supply. Again, that's largely been covered by Mitch, and then finish up with just what we're recommending for companies or municipalities or organizations that are interested in looking at fuel cell vehicles. So first of all, starting with the CHFCA, and by the way, I'll warn you, I kludged this presentation together from a couple of presentations, so you'll still see different formatting in this. I didn't have time to get everything smoothed out and a consistent formatting, so I do apologize for that. But what we are is we're a national association, been around for a while. We represent Canada's leading hydrogen fuel cell sector. We've been around since 2009 in our current incarnation, and for a couple of decades before that as our predecessor companies, our predecessor associations. And what we do is to represent industries that are engaged in the hydrogen and fuel cell value chain by helping with marketing, government relations, education outreach, networking support, et cetera. And really, the whole goal is to accelerate hydrogen energy adoption around the world. We have a growing list of companies. We're over 90 now, and I think this list is now missing some companies. We just had some new members sign up this morning. So we've got a real broad range of skills and capabilities in this group. It ranges from leading companies like Ballard, like H-Tech. It includes international companies in their Canadian operations. It includes tech startup companies, It includes academics. So we're also an academic association. So we have research institutions that are members of our group, and startups that are bringing new technologies to the marketplace. The full range of capabilities, fuel cell products, the components, as you've heard about, the services for that, for testing, certification, and then on the hydrogen side, the production, the distribution, new hydrogen technology, and also a big part of it is around the engineering and project management side of things. So helping other companies to understand how hydrogen and fuel cells will fit into their businesses, even working with other governments to look at developing strategies, and then a big research and development component too. So really, this is something which Canada is fairly fortunate to have. We have this is the Canadian sector is recognized around the world. Our members are involved in projects, everywhere, and that's a real asset that Canada can take advantage of. So why are we here? Well, we're here. We've partnered with Natural Resources Canada to start working on communications and on the implementation of the hydrogen strategy for Canada. The Natural Resources Canada has come out with the hydrogen strategy. They're looking to get that implemented, and we're looking to see, of course, what we can do to support that work. And so looking to raise awareness, looking to address any barriers that may be coming up in the adoption of hydrogen and fuel cells. And why are we doing this? 4 main reasons. Number one, hydrogen is essential to hit net zero 2050. Secondly, it supports other clean fuels, clean power, clean biofuels. It's a Canadian strength, so we stand to benefit from this. And hydrogen and fuel cells provide choice, so that's helps in spurring the adoption of clean technologies. So just talking a little bit more about that. I mean, when it says essential, it's recognized now that hydrogen has to play a big role in getting to net zero 2050. If you're only concerned about reducing carbon emissions, you can get by with energy efficiency, with maybe natural gas. But if you're going to net zero, which we need to do, then you need to have hydrogen as a key part of your mix to decarbonize some tough sectors. The other thing about it is that it supports, for clean power production, you need backup. You need to have additional load for the for renewable projects during the off-peak times, and hydrogen can provide that. And it's also an essential raw material for a lot of biofuel and byproduct production. As you saw from the previous two, it's a Canadian strength. Ballard and HTEC are the tip of the iceberg. We have many companies, and so we can look at growing jobs, getting investment by building that sector. There's over 300 billion in projects identified, hydrogen and fuel cell projects identified between now and 2030, and we can play a big a role in that and benefit from that, and in terms of selling products, selling expertise, and selling hydrogen. We can also start shifting. We're an energy exporting nation, and we can look to shift into the export of hydrogen around the world. And the other really big thing is that we're asking Canadians to decarbonize their operations, to shift their entire way of doing business, to adopt electric vehicles, to change their heating systems, to change their processes. And hydrogen can provide a choice that is in many times the most cost-effective and the most efficient way of doing that. And I think that having that choice is really important if we're going to achieve the net zero goals that we're looking for. So as an essential component, really fits into long-haul transportation, heavy industries like cement and steel, building heat, and energy storage. So those are the sort of the main areas where we see hydrogen being deployed. And where do we stand today? Well, Canada is the world's largest producer of clean hydrogen right now. I just confirmed that. US is close on our heels. They have a big blue hydrogen project down in the Houston area, but we are still slightly larger with a project we have going on in Alberta. And in addition to that, we're the cradle of PEM fuel cell technology with, as Ballard mentioned, over 40 years of history. There's a lot of projects underway across the country. I won't go into them in detail, but there is activity right across the board, looking at fuel cell developments, at hydrogen production developments, and technologies. And that's very exciting, and it's very good news. But frankly, we're lagging other countries at this point, particularly Europe, Japan, Korea, and California. And so, there is certainly room for improvement. And when you look at this, at the challenge of where we need to be by 2050, well, we need to scale up our hydrogen production. We need to install hydrogen distribution and storage grid. All right, we need the fueling infrastructure. We need fuel cell vehicles available, and we need the net zero gaseous fuels available for heating. So hydrogen production scale up, that's the estimates made by the hydrogen strategy are that we're going to need to scale up at least 10x just for our domestic demand, more if we want to start looking at overseas sales. And that all has to be clean, and it all has to be low cost, which is going to lead to it being at large scale. The good news is it can be done, but it is going to take a number of pathways. It's not going to be all done with electrolytic hydrogen or green hydrogen. It's going to have to be done with that, and with also hydrogen from off-peak nuclear, hydrogen from fossil fuels with carbon management, hydrogen from biomass. All of those methods are going to be needed to supply the demand that we're going to be requiring. We need to develop ability to move it from those major production points to those major urban centers. So Mitch talked about the trucking, but we're going to have to start growing that to getting to pipelines with storage similar to natural gas. We're going to have to look at large scale production pathways through ammonia, methanol, and liquid organic hydrogen carriers and liquid hydrogen. And then we're also going to have to build out our fueling station networks. We've started that, but there's 10,000 light duty stations, retail stations in Canada. We need to start out equipping all those stations with hydrogen pumps. And in order to do that, they need to be compact, low capital, simple, flexible, reliable. They need to be supplied with hydrogen either on pipeline from hubs or delivered liquid high pressure gases, as Mitch described. And the nice thing about this, the good thing about it is that those can be self-financing. They can self-finance through the hydrogen sales and through low carbon fuel credits. So it is it's a big task, 10,000, but it's actually a task that can be a business opportunity. We need the OEMs to integrate hydrogen fuel cells into product lines. And as Terry's work has shown, and the buses demonstrate that's very feasible with excellent cost and performance. And that's an area where Canadians excel, and we can help OEMs to do that. In addition to Ballard, we have many other companies that help to integrate hydrogen and fuel cell technology into equipment. And one of the big challenges is also that we need to convert our heating grid to net zero. So we need to convert from using natural gas over time to using a mix of hydrogen and renewable natural gas. That means we need hydrogen pipelines that are compatible with a mix of hydrogen and renewable gas. We need dual fuel appliances, furnaces, and turbines. So it's a lot of work. And in the interim, we need to develop hubs, which should be mixed concentrations of applications around a low-cost production point to move us down the pathway. So the federal government, to support all this, is they've recognized the need, they've recognized the opportunity, and they've come out with a hydrogen strategy. And they've also done the revised climate plan. And there's a lot of work that's being put in place now that really will support the drive towards clean fuels generally and hydrogen in particular. The net zero commitment's a big one. Price on carbon will certainly drive use of hydrogen in refineries and chemical plants. The clean fuel standard, 13% by 2030 of our 13% reduction in our carbon intensity in our fuel base by 2030 will drive both hydrogen use in refineries as well as stimulate hydrogen fueling stations, which can generate credits against that. And they also have put in zero emission vehicle targets. They haven't put in mandates as yet, but there are certainly targets in place that they want to achieve. And they're working to make sure that there's drivers in place to achieve them. They're also backing that with funding, the 1.5 billion Clean Fuel Fund, 200 million in infrastructure, 2.75 billion zero emission bus fund that's got to be spent in the next 2 to 3 years, and fuel cell buses fully meet the qualifications there. 3 billion strategic innovation industry transformation fund. The Canadian Infrastructure Bank has been mandated to support hydrogen with loans. And then there's ongoing research and demonstration funding from NSERC, NRCan, and others. So there's a significant funding commitment to this space as well. They're also engaged internationally through the Clean Energy Ministerial, International Partnership for the Hydrogen Economy, and Global Affairs is getting involved both to really push hydrogen exports and looking for investment, direct inward investment into Canada. So I think the federal government is pretty committed to hydrogen fuel cells, and I think the time is ripe to bring forward projects. BC and Quebec are leading on the provincial side. They have strategies in place. They have supporting policy and funding. They have zero emission vehicle mandates. In BC, we have a renewable content mandate in natural gas, which is driving hydrogen demand there. And in Quebec, they have very low cost power, which is driving companies investing in industrial processes that require hydrogen. And the other provinces are hard on the heels. So Alberta has come out with hydrogen as a major strategy pillar. Ontario, I just came from a hydrogen strategy discussion, and the Maritimes and even North are also looking at it. So there's quite a bit of government activity to drive activity. And for the hydrogen strategy for Canada, they've identified that there's a number of pillars that they need to be implementing. And I won't go through them in detail, but they've sort of identified these are the things that have to happen in order to really drive hydrogen adoption. Things such as the awareness that we're talking about. And the way they've structured this, and I stole this from a government presentation, they've put in place a steering committee, and they're kicking off underneath that working groups to look at specific sectors or specific areas that require attention. So codes and standards or exports, just seeing what we need to do to stimulate hydrogen exports from Canada. We are leading the Urban Transit Task Force, looking at stimulating the adoption of fuel cell buses in municipalities. A mining task force has been kicked off, and there are more. And I encourage participation of the people listening in those task forces, or pardon me, those working groups. And the goal of those working groups, assess barriers, undertake analysis, identify opportunities, share information, and so on. Really look to see what can be done to move things forward. So when you look at it, we've got, the things are coming together for hydrogen. You've got the policy parts are coming together. The products have been talked about are maturing. There's buses available now, and there's other products hard on their heels. Our ability to produce low carbon intensity hydrogen is significantly improving. And just talking specifically about that, I think risk of repeating ourselves. Hydrogen is nice in that it allows electrification of a broad range of vehicles, not just light duty vehicles, but also buses, trains, off-road equipment, and trucks. And that's where it's, really, it complements battery technology. And we can now go to to fleet operators and say, you need to electrify your fleets, and you need to choose what is the right mix of battery electric technology and fuel cell electric technology that really optimizes your needs. Both of those are on the path to net zero. It's really up to what fits most with your economic needs. The costs are coming down on these. This is a trend for looking at where fuel cells are projected to be. And they're, as say, between 2025 and 2030, they are expected to actually get to be lower cost than internal combustion engine vehicles. So the cost is coming down on them. And this is an example that talks specifically about what's happened with buses. And buses are the leading indicator, but they're showing how the total cost of ownership for them has been steadily coming down to the point where they're going to be considerably cheaper than both internal combustion engines and even battery electric vehicles in the future. I won't go into this because Terry talked about it, but there's applications in rail, there's applications in off-road, there's waste disposal vehicles, and light duty vehicles all are available. And then, as mentioned, heavy duty trucking being a really important one, where we have a leading project here in the HTEC project in Alberta, and a lot of other activities. So there's fuel cell truck developers in Canada. There's other projects that are moving forward that are all helping to get us to the point where there'll be commercial trucks available for purchase. Again, don't want to belabor what Mitch talked about in terms of hydrogen, but as far as fueling infrastructure, it's also very viable. You have it's very similar to compressed natural gas dispensing. You have a very compact system that can fuel vehicles quickly, and this has been done for years and done safely, and so it can be readily replicated. The hydrogen supply for that can either come, if it's in the right location, directly from a hub where there's larger scale hydrogen production via pipeline. You can look at on-site production, or you can look at having it brought in as a liquid or a high pressure gas. And all of those are very viable and can give you a cost-effective supply of hydrogen. The nice thing about this, particularly when you start looking at heavy equipment, is that versus charging infrastructure, hydrogen infrastructure can handle a lot more vehicles. What that means is as your fleet size increases, or as your station size increases, for 1 or 2 vehicles, battery chargers are cheap, but they keep getting more and more expensive as you add more of them, and then as you have to start adding a whole new power supply into the depot or the charging or the fueling station. Hydrogen fuel cells fuel cell hydrogen supply systems, on the other hand, it's expensive to get one in for 1 or 2 bus vehicles, but then that same system that supplies 1 or 2 vehicles can also supply 10 vehicles, and with minor upgrades can supply 100 vehicles. So your infrastructure cost drops significantly as your fleet size gets larger. And this has really been shown in locations like in California, where they're doing full fleet conversions. On terms of cost, hydrogen can be fully competitive with diesel. You're always going to have a situation where a battery is going to be cheapest on a strictly looking at the fuel cost, but it's not that different than what you're going to see with hydrogen. And you will be able to see the hydrogen coming in at cost lower than diesel going forward. And we have a problem in Canada that we don't have a broad infrastructure of hydrogen production, merchant hydrogen production plants yet in Western Canada. We have a very good supply in Eastern Canada. We have a couple of plants in Ontario area and in Quebec. But the good news is that that's expanding. And Mitch touched on this. They're building capacity in BC. There's capacity being built in Alberta. Winnipeg Transit is building their own capacity to fuel their buses in Manitoba, and they're estimating their cost for hydrogen coming in at $6 a kilogram, which is, as you go back to this chart here, that puts them in at a price that's fully competitive with diesel today, and where they will be cheaper than diesel going forward. So it is very possible to get the hydrogen supply in and have that be very cost competitive with diesel. The other interesting development is around hubs, and the leading one is in Alberta, where you see a cluster developing of a number of applications being built around a common supply point. In this case, it's a hydrogen pipeline network that supplies the chemical and refining industry there. That's being extended. There's new capacity being installed there to start using that hydrogen to fuel trucks, buses, rail project that Terry mentioned. They're looking at making chemicals for export. They're actually looking at using the hydrogen for running the turbines for power generation. So a lot of work happening in that Alberta area, in the Edmonton Heartland area. So where's all the hydrogen going to come from this? There's a number of ways it could be done, and we are very much support it being clean hydrogen. We think all pathways are needed. So-called blue hydrogen or green hydrogen. We have experience here in Canada. We have the world's largest PEM electrolyzer in Quebec. Just started up at an Air Liquide plant using clean Quebec hydropower to produce hydrogen for export around North America. And we have the advantage that we can build out with our wind and hydro resource very effectively. We also have as I say, the world's largest production of clean blue hydrogen, over 120,000 tons of CO2 captured. That's equivalent to, well, it's a very large amount of hydrogen, and is able to be expanded significantly, and is now the cheapest hydrogen in the world, clean hydrogen in the world. We also have research and development capabilities. And if we want to move forward, I think one of the things we want to emphasize, I borrowed this slide from Winnipeg Transit. And this is they're looking at what it takes to start electrifying their fleet. And they really highlighted the need to dive into the overall cost to your fleet, not just, it's obviously easy to look at the purchase price, to look at range and performance, weight and labor and that sort of thing. But you also need to look at things as they list here: resiliency, your infrastructure, what it's going to take to upgrade your electrical system, and so on. And it requires a considerable study. Every location is different, and usually what it's going to point to is a mixed fleet. So we encourage you, if anybody's going to look at doing fleets, do those sort of studies. Get involved with looking at what are the other applications in the region. Engage some of the consultants that have experience in this area that can help you do that. And of course, there's a wealth of experience in the companies in the Canadian Hydrogen and Fuel Cell Association. And I think I've gone well over my time, but thank you very much. I do appreciate the opportunity here, and look forward to questions.
All right, thanks so much, Mark and Terry and Mitch, for your presentations. Just a second here.
I will stop my sharing.
There we go. So we have a number of questions come through in the Q&A feature. Please feel free to post any other questions that you have. I'm going to start with one that's come through from a couple of people. Is in Manitoba, we build a lot of big, heavy things on rubber wheels. So everything from farm equipment to, we got four-wheel drive tractors done here. We got self-propelled swathers, all kinds of different vocations, fire trucks, snow plows, airport snow plows. So I'm going to pose this one to Terry. What is a good fit for hydrogen, and what maybe isn't so much a good fit for hydrogen as a fuel today, and then look into the future?
When you look to zero emission vehicles, one of the drivers is range of the vehicle. So as I think was said, for the infrastructure, one single vehicle, the battery charging infrastructure is simple. If the vehicle doesn't need long range or heavy payloads, then batteries are probably the right solution to that. And so an example to use of how it differentiates. So the transit buses. So right now there's a lot of transit agencies, as they roll out their zero emission plans, are using mixed fleets, and that's because for transit buses that only require 100 or 150 mile range, battery buses can do that. If you start to look at routes that require more than 150, you end up having to either do on-route charging, which is very problematic or expensive, or having to get multiple buses to do that single route. And so there's an example of where fuel cells are the right choice for that. Another example is refuge trucks. So if in a case where the transfer station may be a ways away from the route where they're collecting their refuse, and there's highway driving before and after the route, that heavy haul, high speed, long range is where that's the sweet spot for fuel cells. So hopefully that gives some examples there.
So let's say that I had a four-wheel drive tractor, large four-wheel drive tractor, and I was cultivating a field or planting or those kinds of things for 10 to 12 hours a day. And I'm making these things and I'm looking for the path to zero emissions. Should hydrogen be considered, or is there
I would say it should be considered, but I'll be also upfront that it's not one of the applications we have looked into. So I don't think I can speak too much about it, other than that I am familiar with, there are in Europe some activities to integrate fuel cells into agricultural vehicles. So I know it's on some of our competitors' roadmaps. It's not been an application that we've been focused on to date, but it may make sense. I'm just not 100% sure.
Yeah, and you would think that the duty cycle would be similar to a mining truck, for instance, right? Just loaded up in a long haul with lots of weight would be sort of a similar duty cycle.
Well, I'm sure, based on the duty cycle, I'm sure there's no interest in stopping the vehicle to recharge it halfway through the day. So that will be the test to see, how applicable is the battery technology for that application. If it's not, then hydrogen fuel cells provides a zero emissions.
Okay, thank you. Next question is, there seems to be a bevy of colors when it comes to hydrogen. I've heard of purple, I've heard of green, I've heard of blue. Can you, either Mitch or Mark, could you walk us through what each of these is?
Shall we take this, Mitch?
Sure. I think we'll try and simplify it, I guess, is that, yes, there's always a lot of different colors that are talked about. I guess the three main ones would be gray, which is SMR, natural gas based, where carbon capture is not put onto it. Then it moves to a cleaner source, which is blue, where you have the same steam methane reformation of and then the carbon is captured and sequestered, and you can get up to or over 90% of the carbon sequestered. And then you're into green, which is electrolysis from clean electricity. Generally, we've started using terms related to carbon intensities, and it's a bit of a debate. I think we use the colors because it's been used before, but we're really wanting people to, I guess, consider the carbon intensity of a various, because hydrogen can be produced in so many different ways. So I think really that's what people should be starting to consider, is just understanding that there is a variety of ways to get to a low carbon intensity hydrogen. And the colors are just one way of explaining how that can be. But I think going forward, the path is fully towards low carbon intensity hydrogen. Everyone knows that that's what we're going to need. Mark had mentioned that, is that, we need 10 times the production that we currently have, and that's all going to need to be low carbon intensity. So that will come from a variety of pathways.
Okay, and that leads actually nicely to our next question here about the using waste streams to refine hydrogen. I guess refine would be the right word, refine hydrogen to fuel grade. And we know that we have a fertilizer plant in Brandon that I know some people that are in the hydrogen world are very, very excited about, that could potentially be a path to manufacturing hydrogen here in Manitoba. Is it practical to look at waste? Is it more practical to look at waste streams, or is it more practical to look at electrolyzing?
More practically, the first thing you want to do is capture all your waste streams, and that's, if you got one available, that's the lowest cost source of hydrogen you're going to find. And so we're seeing that around the world, that there's everybody's looking to gather up those waste streams and put purification and dispensing and dispatching systems on them. I would say that the key barrier to that is demand, and so that's a great asset that is there, but now you need to start thinking about how do you build demand around that site or close to that site. And probably the best way to do that is to start seeing if you can attract some bus deployments, light duty fleet deployments, and start getting in line for getting some trucks in place. That way you can get the demand in place, which will justify the equipment required to capture, compress, and dispense that hydrogen. But I think that that's certainly the first thing you want to do. And then as you move forward, you can look to add additional hydrogen capacity by adding electrolysis capacity to that, or other means of producing it from municipal solid waste or whatever else happens to be available as a raw energy source. But certainly you want to take advantage of those byproducts.
Excellent. Thank you. Aaron Cook from Winnipeg Transit is asking, considering a mixed fleet of battery electric and fuel cell vehicles, could a hydrogen fueling station with storage be paired with a Ballard stationary power system to provide backup resiliency for charging in the event of a power outage? Has this been demonstrated anywhere?
Terry, you want to take that one? I mean, yes, that's been looked at.
I'll give my answer, and then you can correct me, Mark, because I'm not aware of it being demonstrated anywhere. Certainly, there's no technical reason why it couldn't be. So certainly, if Aaron, if you're considering it, we'd be interested in discussing it. But there's no technical reason why it couldn't be. Obviously, there's a lot of requirements review as far as amount of hydrogen and the value prop that it could have. But certainly, it's doable with today's technology. We certainly have the products for it.
It's interesting. Another interesting wrinkle to this is one of the, like in Manitoba, peak power demand basically drives our cost of electricity here, right? So if you have a backup hydrogen system and you can make 1.5 megawatts a day or draw 1.5 megawatts off of a Ballard system, could it be used as a microgrid, if you will?
Yeah, I think it could be used as a peak shaver to lower that peak, and that's in fact that's the exact application that our 1 megawatt system operating in California was being used. So I think it was operated from I want to say from about noonish till about 6 p.m. every day for 5 days a week. In that application, definitely a sweet spot for fuel cells. Yeah.
Okay, go ahead.
I think energy storage is an interesting one. I mean, it's something which is needed for a lot of renewable power systems, and I think there certainly has been some demonstration projects done where people have generated hydrogen, stored it, and then use it to make electricity again during demand times. It's usually not as competitive as going with batteries or other energy storage methods. Quite frankly, I think that it's because of the losses you get in the round trip. It's tough, but it has got certain niches where it works very well. Particularly if you look at things like as Terry I think mentioned, the big data centers where you can store a whole bunch of energy in a liquid hydrogen tank, have it wait there, and then they absolutely need that power 24/7, and so you can have that thing kick on and start producing power right away in a smooth way. It works really well in that situation. But I think that for most sort of power smoothing operations, batteries are a pretty good competitor in the short term. And then in the long term, what you're going to want to do is have it, connected to your heating grid. So you're going to be wanting to use your surplus power to go into the heating grid, and use it that way as a demand for your off-peak power.
Excellent. Thank you. So Aaron has another question here. NRCan funding for fueling infrastructure is available for light duty stations, not commercial stations. Are there any plans for the federal government to release new infrastructure funding more aligned with the needs of heavy duty commercial applications? I guess, Mark, this one probably falls in your lap.
I think the short answer to that is yes. There is intentions from everybody I've talked to, but when it's going to come out, what it's going to look like, and how much money is going to be involved in it, well, let's see what happens coming out of the budget. I certainly know that there's money in BC that they are making available for heavy duty stations, and I'm certainly, we're hoping and advocating for there being infrastructure money available for heavy duty. There's this $1.5 billion clean fuel fund. It's not yet clear what that's intended for. It's not clear how much it's, how it's going to be administered. But again, it is meant to enable clean fuels, including hydrogen. So we're hoping that it enables both production, distribution, and dispensing of those products. But I wish I gave a definitive answer. I expect there will be something coming out very soon. It's recognized that heavy duty is an important area and that we need to support it. And so we'll see if the government's listening, and I suspect they will be.
I do think, Mark, and I'm not 100% sure about this, but I know under some of the programs that we've looked at where we've done for our light duty stations, I use the acronyms, but so EVA, FEED, and then there was ZVIP. There's two separate kind of funding sources. I'm pretty sure this year they've made announcements to talk about heavy duty under that, but as of right now, they are not. There's no time of when that's coming out, but I expect that to be this summer in line. They generally do calls in the spring here, late spring. So I'm hoping, Aaron, that's going to open things up for that as well. But it feels like they've almost combined those two different paths into one maybe this year. So we'll see what that brings going forward.
Great. One question, this would go to Terry, is we know diesel quite well. We know that we bring it in every so many kilometers for an oil change. We have to change the transmission fluids here, the filters, those kinds of things. What does a normal maintenance cycle look like on a hydrogen fuel cell vehicle?
Yeah, so there's a few, the typical maintenance items are filters. So there's an air filter that is both particulate and a chemical filter for the air. There's particulate filters for within the ventilation system, and there's a deionizing water filter in for the cooling loop. And then those are the typical, and they're filters. So to some degree, the frequency changes based on the operating environment. And then beyond that, there would be potential corrective maintenance items. And if you look at a fuel cell vehicle today, the fuel cell stack itself is the most reliable component on the bus. The fuel cell stack, the system has sensors that are air compressor. Those types of items may require corrective maintenance every once in a while, but otherwise, the maintenance of these products are, if we look at our bus fleets, are being done by the same maintenance staff that would be maintaining the diesel buses. So it's the same skill sets that are required.
Excellent. So we've got 11 minutes to go here. I've got the questions are coming in like crazy, so I'm going to do some rapid fire stuff. Unfortunately, reading some of these questions, I don't know that the answers are rapid fire, but not solely fuel cell related. Are there efforts to capture, store, and distribute hydrogen produced as waste byproducts? We talked about that. Are you looking at hydrogen as a combustible in aerospace applications?
Are we? I think that in our association, there are certainly people that are looking at that. There's Airbus. Actually, there was a conversation just yesterday in Quebec. Airbus, Pratt and Whitney are both very interested in hydrogen for aviation. In that case, it can be used in two ways: in the lighter vehicles, short takeoff and landing, and drone type applications. It would be fuel cells and hydrogen. As you get into larger planes, it's using hydrogen in turbines. So yeah, it's certainly being looked at. Airbus came out with a bold statement that they are going to be moving to hydrogen as a primary propulsion fuel, in sort of post 2030 timeframe. So there's a lot of activity there, but it is aviation is a long, slow market. It takes a lot of time to get things proven and tested and certified and so on. But I think that work is happening. I'm a little disappointed that Canada, which is I think the number 7th largest aircraft manufacturing or aircraft equipment manufacturing country in the world, we are not yet having an active program in developing technology around hydrogen fuel cells in aviation. I say Pratt and Whitney, Airbus, and others are exploring at this point, but we have not got a serious program underway. And that compares to places like the UK, Orkney Islands. They're doing, they've got conversions happening on light planes right now. There's just a lot of activity happening in other parts of the world, and it'd be nice to see something happening in Canada.
Okay, Bob Parsons, who's with the University of Manitoba, very passionate about electric vehicles and zero emissions. Sourcing hydrogen is a bigger problem to do economically. Manitoba used to have a strong interest in hydrogen, but that was due to our low cost electricity. Now, however, given very expensive new projects, Bipole and some of the others, we no longer have a low cost hydrogen, and electrolysis is looking increasingly unviable. How do we do this economically? By the way, we have byproducts, but as understood, it is now already taken. Any comments there?
Well, I think it's absolutely. I mean, hydrogen is going to be needed in Manitoba, like every other place. It's going to, be needed to decarbonize a lot of the heavy transportation. It's going to be needed for your trucks. It's going to be needed for other things. So Manitoba needs to start thinking about where it's going to get its hydrogen from. It can import it. I mean, I know Alberta will be very happy to be selling you cheap, clean hydrogen, and so it can be brought in via pipeline from there, or it can be made using energy sources in Manitoba. I agree, hydro is a valuable form of electricity because it's a demand electricity. It's probably best used to back up renewable systems rather than being dedicated to make hydrogen. So I would say it needs to attract renewable power developers for wind and solar projects that can be used to dedicate to production of hydrogen and be smoothed and backed up with Manitoba's hydro, and that will be fairly cost effective. But it is something that Manitoba should be looking at as to what is its method to get its supply of clean hydrogen, so it's not disadvantaging its industry and its individuals. Ontario has got an even bigger problem because Ontario has got a need to grow its clean power. It's probably going to wind up being a net importer of hydrogen. Quebec's in an enviable position. They've got a very good wind resource as well as their hydro. And then there's of course the fossil fuel thing, hydrogen. But I think it's it requires some serious look by the utilities and by the government and by private sector to start seeing what is going to be the cheapest way for Manitoba to get its low-cost hydrogen.
Here's a question. Is green hydrogen really green hydrogen when it's shipped by a long-haul truck powered by diesel?
I think that in all transportation and indirect for all industries, whether you look at our mining industries, whether you look at our lumber industry, the indirect or level 3 GHG reductions are in their supply chain. How do you start lowering your carbon intensity of the way you move your product to market? And hydrogen is the same thing. Hydrogen producers will have to start looking at how they decarbonize their transportation networks as well. So they'll have, I think, a good opportunity to use hydrogen in those vehicles as the heavy duty Class 8 trucks become available. They'll have the advantage of having lots of fuel on the back, but so they will be able to be decarbonized like other means of transportation. So I think that a hydrogen grid or hydrogen infrastructure needs to be decarbonized in the same way as our power grid needs to be decarbonized. If you look around the world, Manitoba's lucky, but many other jurisdictions are not. They need to look at how they're going to decarbonize their power production. Hydrogen's the same way. We need to be looking at the full cradle to grave. What does it cost to? What is the carbon intensity? We need to be certifying that. The clean fuel standards that are being developed and the clean federally all have processes for certifying fuel pathways, whether that's a biofuel, a gasoline, whatever it happens to be. You certify your fuel pathway as to what its carbon intensity is. Same thing's going to happen in hydrogen, and that's going to have to be verified. And interesting challenge is, do we need to get into blockchain technology for that? Do we need to, are there other means to do that? But certainly that's going to have to be done, and it's going to have to be done with international standards and grades for that hydrogen.
Okay, and I think our last question of the day is from John Cherwinski. As far as the cascading equipment is concerned to support hydrogen cell buses, there are challenges in HVAC performance, especially in certain states in the US further south. The main issue being space claims for additional equipment to support effective heating, ventilating, air conditioning performance. Are there any comments, design restrictions that we can circumvent the footprint of certain equipment, or has this been an issue which has been considered?
Say that one again. Is this is using hydrogen for heating? Is it?
Yeah, I think this goes to Terry, and I think it's about the space claim of the hydrogen fuel cell equipment and having to cool a bus in Houston, Texas, for instance, and the space claims of the AC equipment and the space claims of what's needed to achieve range in hydrogen are probably conflicting, and you almost need a 45-foot bus to be able to do both, is kind of what I'm reading into that question. Do you have anything there, Terry?
So assuming you're talking about the heating and the cooling of, say, transit buses, then certainly to date it's been a challenge. It's a challenge for battery buses as well, because you're using a significant amount of the energy just to either cool or to heat the environment where the passengers are sitting. But year on year, the fuel cell technology is improving, and we're operating at warmer and warmer temperatures, and that technology improvement is pushing us closer, certainly helping us heat the buses, because the fuel cell product also creates heat in the form of that then goes to hot water that can be used to heat the passenger area. And as we get warmer and warmer with that, we'll be able to utilize that for air conditioning purposes as well. So that's where the technology roadmap is going. So we see again that fuel cells will have an advantage over batteries as far as that goes.
Okay, and then a couple of Terry, you talked about a prototype fuel cell power on a highway truck running in Alberta. That's actually, I believe those trucks are hitting the road in November this year, right?
Towards the end of the year, that's right.
Yeah, and if I'm not mistaken, trucks are being outfitted Dana TM4 in Quebec. And once the infrastructure is up and running, they'll be running, I think, 60,000 pounds back and forth from Edmonton to Calgary and back on a single load of fuel.
Yeah. So I saw the question. The challenges are probably with all of the large trucks. Probably the single biggest challenge is packing enough hydrogen onto the vehicle. Right now, typically the hydrogen's being stored at 350 bar. As we can go to 700 bar and more, the limitation is not necessarily on the technology that goes onto the truck, but it's the availability of the fueling side to pressurize the storage devices to 700 bar. So as we go to that, and that becomes more commercially readable, that problem will diminish a little bit, as well as there are companies like Chart Industries that are working on liquid hydrogen storage vessels that go right on the vehicle as well. So again, all of that is going to pack more hydrogen onto the vehicle that then allows the vehicle to have more range.
Well, that's fantastic. Well, we are at 3:31, and I think it's time to end. I thank you, gentlemen, for enlightening us on hydrogen fuel cell technology. And thank you to everybody that's been on the webinar for your questions and interest in this subject. We will be posting this entire webinar on our website at btci.ca. Should have it up tomorrow morning. And so if you know of anybody that's interested in the subject and wasn't able to attend, feel free to direct them to our website. So again, our thanks to Terry, Mitch, and Mark for presenting to us. Their contact information was up on the slide throughout most of the Q&A. So if you have applications that you want to speak, or questions about policy or those kinds of things, you've got the people right here that can answer them. So I thank you for your time, and have a great afternoon.
Thanks much. Appreciate the opportunity.
Thanks very much.
Thanks, Aaron.
Great, thanks, guys.